Good afternoon to all. I heartily welcome you all for the third section. Now the section over to MC section. Anita ma'am.
Welcome back to the third session. Dear participants, those who are all could not able to join in Google Meet, kindly use the YouTube streaming which was posted in the chat box for third session. Kindly make use of it. I call upon Mrs. M. Ilakya, Assistant Professor, Department of Physics, to felicitate Dr. R. Thangappan, Assistant Professor of Energy Science and Technology, Periyar University, Salem. Welcome you, ma'am.
Good afternoon to one and all present here. I am highly honored and feel privileged to have been given the opportunity to introduce the speaker, Dr. R. Thangappan. He completed his BSc Physics at Mahendra Arts and Science College, Salem. Also, he completed his MSc Physics at Pachepas College, Chennai. He completed his PhD Physics at Center of Nanoscience and Technology, Anna University, Chennai. Sir's passion on teaching made him to work as a visiting lecturer in Department of Physics, Dharmambal Government Polytechnic College for Women, Chennai, during the period July 2008 to December 2009. During the time of PhD, he handled classes for MTech and MSc students at Center of Nanoscience and Technology, Anna University, Chennai. He worked as an assistant professor in Department of Physics, Bharat University, Chennai, during the period September 2016 to February 2017. Now he worked as an assistant professor in Department of Energy Science and Technology, Periyar University, Salem. Sir has received DST Pure Fellow during his PhD at Center of Nanoscience and Technology, Anna University. He has published 17 research articles in internationally recognized reputed journals. He has reviewer for more than 10 journals. Sir has organized 4 workshops and 3 conferences in nationally and international level. Sir has attended and presenting papers in 14 international and 17 national conferences and workshops. He has carried out many research projects in the field of nanomaterials. His area of specialization is nanomaterials for supercapacitors application, solar cell, energy harvesting, and energy conversion. He is professionally trained to operate and troubleshoot the instrument like atomic force microscope, particle size analyzer, FEM, powder X-ray diffraction, etc. Sir has guided MTech, MPhil, and MSc students for the research project. Currently, one student is doing his PhD work under his guidance. We feel very happy to your presence here, sir. Now, I request our distinguished chief guest, Dr. R. Thangappan, to take over the section. Welcome you, sir.
Thank you, madam. Thank you for your kind introduction. Can you hear me? Hello.
Yes, sir. It's audible, sir. It's audible, sir.
Thank you. Thank you.
Welcome.
Thank you for a kind introduction, madam. And also, I thank the organizers, principal and vice principal, and the convener of this international webinar for giving opportunity. So let us move on to that today's topic, lecture. My slides are visible. Hello.
Yes, sir. It is visible, sir.
Full screen is available. Full screen.
Yes, sir. It's visible,
Okay.
sir.
Okay. Thank you. Okay. Today I have Energy Science and Environment of Energy Science and Technology, Periyar University, Salem. Okay. Coming to the topic, it is humanity's top 10 problems for next 10 years. First comes that energy. That is, energy is the foremost one for everything. So that only it comes first. It is a top 10 problem within the top 10 problems, because energy needs each and every thing, every technology, or whatever, every product or whatever, every application, the energy needs to for activate the anything. So that only energy stands first. And also the demand of energy also day by day increases, because the necessity of the human being of energy is increases. And also the population also increases day by day, so that the human being need energy also day by day increases. So that only energy is foremost one in the top 10 problems. Okay, and then also we have many problems in energy. We cannot produce much amount of energy because the demand of resource in available in the earth. In few after few decades, the natural resources will be in demand. After that, many problem occurs for producing the energy, so that the people are moving towards that alternate source for the producing energies, that is renewable energy sources, that is solar, wind, like etc. Already we are whole world is focusing on renewable energy. In future, majority of the all kind of applications will be work on the renewable energy only. The kind of work is going on, there are research is also going on the renewable energy sector. That is the major criteria of human 10 problems. And next comes the water. Know about water. You know about water, that is the demand of how much water due to the climatic conditions and disasters. You have the lack of waters, and you people are about know about that many natural, human occurred errors, that is an installing that mines, everything. Also this groundwater level also going down, and also we are polluting the many kind of waters in like installing that dyeing industries and many kind of industries like that. Although because of that the water is polluted, there also comes and demand. Without water we cannot do anything. That is a major issue. And based on that only food also third problem. What if water is demand is in comes
Excuse
second
me,
problem
sir.
is for, excuse me, yes,
So please hide the Google Meet link that is showing in the.
what, hello, I cannot hear you, sir, please tell me. Hello, hello, organizers, can you hear me?
Yes, sir, it's audible, sir. You can proceed, sir.
Is somebody asking something about what, I don't know what he is asking.
Yeah, hello, sir.
Yes, yes,
Sir,
yes, sir.
please remove the link that is showing the Google Meet link
Yes,
at the
yes,
lower portion of the slide.
hide, yes,
Hide.
yes,
Okay, thank you, sir.
yes, it is removed.
Yes, sir.
Yes,
Thank you.
it is removed. Okay, okay, thank you, thank you. Okay, next thing is coming to the environment. Environment, it is we have many problems. That is a pollution. Due to pollutions, that is we are humans are more polluting the surroundings because of their necessities, building construction, and also we are cutting the trees, everything, so that we are polluting this many kind of problems to the surroundings. And next comes the poverty. Because of the lack of food, water, everything, and all, the poverty occurs, and then the employment and many issues. The poverty occurs in many countries. Many people are suffering, like Somalia. Many countries are they are there for the without food, and South Africa, like that. Like that, it comes to the fifth problem. And sixth is the terrorism. All people, know about the terrorism and war. Now the Ukraine war is going on because of their issues, many issues that between the two countries, Russia and Ukraine. Like that, many issues are going on. Afghanistan and many countries are going on. And then disease. Most of the people aware about the disease also. Now we have faced many problems in COVID-19. Like that, unknown diseases will be spreading in because of the many problems occurred by the in the world. And education also one of the many issues is going on in the education. It is a lack of education, and also because of population, many people doesn't educated. Poverty, because of poverty and lack of many uh, issues, we don't have much education in that. And democracy also, Many countries are still now is for fighting for the democracy. And then last one is in population. Population is a major problem in the humanity. That is, day by day the population increases. In 2050, it will reach to 8 to 10 billion peoples in the world. So these are the 10 problems, humanity problems occurs. And foremost one is energy. Okay. Coming to this energy demand, that first one, that is energy. We in this talk we'll talk about the energy only. So that we some statistics of energies. There is a total world energy consumption by the source is, that is in petroleum, coal, and natural gas is 78.4%. In that, remaining percentage are energy, that is 19%, and nuclear 2.6. In renewable energy 19%, we have sort of many categories, that is traditional biomass, bioheat, ethanol, biodiesel, biopower generation, hydropower, wind, solar heating, solar PV, solar CS, like that, with many percentage divided. Look at that. There's then many majority of the energy is coming from the fossil fuel only. That is 78%. Remaining small amount of percentage only is coming from the renewable sector. This will be drastically will change, because after a few decades, I think so. The whole world is now focusing on renewable energy. And then next graph, we are showing about global average rate capacity kind of additions by type, that is entire type of resources. And previous years, that is 2000 to 2016, that the usage is coal, gas, nuclear, renewables, that is almost gigawatt, that is 100 to 120. And then after 2017 to 2040, they will coming to look at this renewable energy takeover, that is about 160 gigawatts, and remaining will be reduced. This is a focus of the many countries. Coming to India, that is, then he have the 175 gigawatts renewable. In 175 gigawatts, only 18% of 18.9% renewable sector in entire power consumption in India in 2022. If you look at the graph from previous years to current year, the gradually increases. That is, energy consumption, power consumption is gradually increases year by year. It shows that the necessity also increases, so that the production also should increase. But the production day by day is it cannot come over reach the equalize the demand because of the lack of resources. That is a major issue. And next we have we people know about that automobiles. Nowadays automobiles are very major use for the many peoples. And in previous years, that is 2016, it is only below 10 million cars in all over the world. And in 2025, will come that is around 50 million cars. And in 2040, it will we can see that drastic change, that is 300 million cars will be there. In that, India will reach about 200 million cars, 2 to 220 million cars. That is, in olden days, you can see that each and every house will have one cycle, and after that, after some few decades, have one bike, and next thing we have one car. Thus nowadays we have all the people, each and every house we have one car. So that the usage of renewables increasing. The increasing in automobiles means we should have a resource for the running, that is energy for running the automobiles. Nowadays the government also focusing on the electrical vehicles because of the lack in the fossil fuels, so that it can equalize the energy demand. Indian scenario, that is in energy consumption by sector 2020, we can see means how much percentage in the transportation, industrial, residential, commercial, electric power, like that. In coal, 23%, almost 100%. In 100%, 23% in coal come from, 22% in natural gas, 34% in oil, and renewable energy 13%, and nuclear electrical power, that is in 8%. In that, transportation will have a majority of percentage, it is 87%, remaining only small percent, 10%, 3%, like that. Industry will have a major contribution, that is 36%, and residential commercial also a major contribution, there is 78%. Electrical power has a 33% only. Like this, the consumption of fuels will be in majority will take place transportation only. Depends upon only that all the prices will be there. That is, and total power generation including the renewable sources in India, that is up to this year, 2021 to 22, we can see that each and every year that units of power generation increases. It shows that utilization of power is also increases. Each and every people needs an energy, so that people population increases year by year, and also the generation of power also increases, then energy demand also increases. That is the meaning. Below that, that is the share of fossil fuels in power generation. That is in 2022, we have a coal 52%, and natural gas 10%, and a large hydro for 17%, small hydro, and solar CSP, and the other offshore biopower, like that. It is remaining percent only. Majority of in these figures and all, we can came to know that the majority of energy is coming from the fossil fuels or natural resources only. That is an scenario of the Indian scenario. And also in renewable energy sector, India has some MNRE has a target in renewable energy target, how much you should install in the future. Like in the year 2022, we have installed 20 gigawatts in solar field, and the wind 60 gigawatts and 10 gigawatts and 5 gigawatts are all. These are all the targets for the installing the renewable sources. But we also achieved the majority of gigawatts in the particular fields and all. These are the some scenarios of energy demand, how much demand we are having all over the world and India. Coming to the topic, in this talk, I will give the basic knowledge about the energy storage, and then we'll go for some examples for the electron materials for energy storage systems. First of all, the energy storage system. Energy storage system is an energy system technology that can help ensure a stability of electricity and reduce power consumption. That is an energy storage definition. Advantages: low carbon electricity and free and new generation capacity, and all that is all we know about that. Types of energy storage systems, many types are there: chemical energy storage, and electrical energy storage, electrochemical energy storage, mechanical energy storage, thermal energy storage, and all. And these are different topics have divided into many areas. It depends upon that energy division. And in that storage, batteries plays a major role in energy storage system. That is the major criteria of storage system in the energy storage devices. In that, batteries is a device that transforms chemical energy to electricity. It has two electrodes, cathode and anode. The figure shows that anode and cathode, and flow of anode and cathode will be there, electrolyte will be there, connected to the load. That is an batteries configuration. History of battery is 1792 itself. It is then invented by Volta, and then by the previous years. And then as subsequently the major discoveries came back, and with the different electrodes and different electrolytes, like that. Depends on that. Lithium metal rechargeable batteries in 1983 is discovered, like that. The discovered when the battery is discovered. Battery's history means the modern battery was discovered by the Alexandra Volta in 18,000. And the ingredients are used as zinc and saltpeter and silver only. There is electrochemical reaction. We can see the figure that is stacked. That is, electrodes are stacked one by each other. That is zinc plate, a silver plate, a zinc plate, and blotting paper. And finally connected to the two ends, it will have the energy storage in between them. Types of batteries: primary based, secondary batteries. And standard modern batteries are all zinc carbon batteries, alkaline batteries. Lead acid batteries, I know about the lead acid batteries, I think so. Many of the now automobiles are using lead acid battery only because of it is flexible and the cost effective. And nickel cadmium batteries, and then nickel metal hydride batteries, and lithium ion batteries. You also know about the lithium batteries also. All the mobiles are using lithium ion battery. Lithium nowadays is coming lithium polymer also. Alternative batteries for the energy storage system. Future, many of the applications will be based on lithium based storage only. It is because of its high energy density and power rate and cycle life and costly. It is highly versatile batteries used in many applications. Why the lithium batteries are highly useful means it is very smaller and lighter compared to other batteries. It is nickel based batteries or lead acid batteries. You know about the thing. So lead acid batteries are heavy weight, but lithium ion batteries are very light because of its atomic number, lowest atomic number. You can see that gravimetric energy density and volumetric energy density. We can, lithium based ion batteries will have a majority smaller and also lighter. Applications, you know about that. Many applications there are battery, without battery, no without battery, no devices can be run without batteries. In the lithium and cell configuration, how it look like mean, and there's a cathode have a lithium iron phosphate and the graphite is an anode. When the lithium ions will be intercalated in the graphite structure with during the charge, and then lithium will be discharged towards the cathode region during the discharge. Like that, it goes, the cycle goes on, and then load is connected between anode and positive cathode. That is lithium-based materials. We have a different kind of batteries. There is lithium carbonate, lithium hydroxide, lithium metal, and butyl lithium, and lithium specialized like that. Depends upon applications. They are being used as the different materials, lithium-based materials. Have a different lithium battery cars and ceramics, cement, aluminum, like that. Lithium hydroxide have a lithium grease like that. Many applications lithium-based materials. Okay, that is, these are batteries. Coming to the capacitors, we are in some kind of small amount of work we are doing in our research labs in the supercapacitor applications. Okay, capacitor is invented by the German cleric Edward Georg von Kleist on 11th October 1745. First invented by the Leyden, the name is Leyden jar. Leyden jar means it have one brass material, and so the central core has a brass material and inserted in the jar. With having the surface with the lead foil inside and the lead foil outside also, and then we can connect the outside foil is connected to the ground and the positive is connected to the brass, and it will have a charge between in the jar, store energy stored in the jar. That is the first invention. And in the capacitor. Capacitor, all know about that. It is it's also known as a condenser. Have a two-terminal electrical component used for store the energy in electrical field. It is a common one. It is, when it scientifically tell, means it is a potential difference across the conductors. If a static electric field develops across the dielectric, causing the positive charge to collect on one plate, negative charge on another plate. Energy is stored in form of electrostatic field. That is an scientific explanation. And have a figure. We have one anode and cathode. How the connector will be between the load. And then supercapacitors. Supercapacitor, also known as ultracapacitor, is an electrochemical capacitor. Usually has a high energy density when compared to the common capacitors, particularly in the automobile application, fired vehicles, as a supplementary storage for battery electric vehicles. It is being used nowadays. The bar kind of application, that is supercapacitor like a bar, is used for energy storage application also. There is some industries also manufacture this kind of one, and it is used in commercially. Why supercapacitor been used? It is supercapacitor is known for 50 years, and in Earth itself has some capacitance value. We have a 0.0007 farad. This is an Earth farad capacitance value, and supercapacitor is able to store deliver high energy densities, relatively high rates. Beyond those, accessible with the batteries, and a high specific power of 55,000 watt per gram can be reached. And also has a high reversibility. That is a major thing. And also the repetitive charge discharge cycling also. The cycle life of 5,000 cycles are demonstrated in this. Working of a supercapacitor, it is energy is stored in ultracapacitor by polarizing the electrostatic solution, and between that is anode cathode will be there, a separator will be in between that, and will be charge will be separated between the two electrodes. That is then capacitance will be calculated by the distance dielectric constant of a medium into area of a plate divided by the distance between the two plates. That is an capacitance value. Okay, that is capacitors are divided. Supercapacitors are divided into two categories. That is double layer capacitors and pseudo capacitors. That is charge storage takes place electrostatically. That are double layer capacitors. Pseudo capacitors will takes place electrochemically. That is an pseudo capacitors. That is double layer capacitors. We are having the examples are activated carbon, carbon aerosols like that, carbon nanotubes, graphene, carbon derived materials, or carbon materials. That are all they will obey the EDLC behavior. And pseudo capacitors are all metal oxides and conductive polymers that will have behavior like pseudo capacitors. In the hybrid capacitors means that is an charge storage takes place both electrostatically and electrochemically. That is an hybrid capacitor. That is an combination of pseudo and pseudo capacitors and ELC behaviors. That are composite materials or reachable battery type like that. That is electrochemical electrochemical double layer capacitors. These will behave in the carbon-based materials. It is store energy absorption and the ion absorption. They will not have a redox reaction will not take place in the material, and also have a high surface area. ELC will be, if the ELC behavior is there, means there will be a high surface area, but it will be carbon-based materials like graphene, carbon nanotubes have high surface area like that. It will have an high surface areas, and the capacitance value it is reached for DDLC means 100 to 120 farad per gram in non-wax electrolyte, and aqueous electrolyte 150 to 300 farad per gram in the EDLC behavior capacitors. Potential distribution, that is in ceramic and film capacitors, etc. It will the electrostatic storage it will be there, and then in electrostatic storage in also takes place in oxide layer materials. And supercapacitors, electrochemical ray capacitors, that is the double layer and pseudo capacitors. Helmholtz ray will be formed between the that is electrodes, the upper that is surface of the electrodes, and then in storage will be electrostatic storage and electrochemical storage. Advantage related to batteries: very high rates of charge and discharge, little degradation over hundreds of thousands of cycles, good reversibility, low toxicity of materials are used, high cycle efficiency, that is 95% or more. That can be used because of that only supercapacitor are used in many applications. That is common layman example difference between the supercapacitor and battery is that is we can say the Usain Bolt, that is an more power required for small time interval in 200-meter race, but it is a constant but less power required for large time in 20-kilometer race. That is an battery, that is supercapacitor. It is common layman example. Coming to that, that is a specific power against specific energy. In that specific energy, with the specific power, supercapacitor covers the majority, that is 0.1 to 10 watt hour per gram. It is because of energy is very high, and also power also it ranges very high compared to other batteries or fuels capacitors. Application of supercapacitors depends upon the discharge time. It is used in many kind of applications. It is 1 milliseconds means in cameras like that, and mobile phone like also. Cylinder type, it is also used in the storage purposes. Coin cell, it is used in laptops or mobile phone, etc. Depends upon the discharge time. It is used in many kind of applications. And nowadays cars also having the supercapacitors for supercapacitor bars for storage of short time storage applications, short time duration applications. And you can see the many kind of supercapacitors like a bar or a shell or whatever, many kind of designs have been used supercapacitors. Okay, these are about the basic storage devices, that is supercapacitor and all. That is coming to the materials, how the materials will, electrodes will be fabricated, and how the technology is used for that. Nanotechnology is used for preparation of this electrode materials used in the supercapacitors. That is first introduction of nanotechnology is Richard Feynman. It is a man who discovered about the nanotechnology. 1918, so he discovered May 11. He discovered that about he's born in 1918, and he died in 1988. The development of quantum electrodynamics, and Feynman received a Nobel Prize in physics in 1965 jointly with Julian Schwinger. And also he in 1959 he talked his talk on top-down nanotechnology called as "There is plenty of room at the bottom." This is a very famous lecture given by the Richard Feynman. In that talk only many scientists have been known about the nanoparticles, how the have been behavior is there. And also the Richard Feynman lectures are many there in YouTube's also. And many, not only scientists, he also in humanity, he many things he published. This is for example of a buckyball structure. That is, and coming to the nanotech, what is a nanotech means? There is art and science of manipulating, rearranging of individual atoms and molecules to create and useful materials, devices, and systems. That is an nanotechnology. Size will be in a nano range, that is 10 power minus 9 meter. Nano manipulation is building up from bottom up. That is a few examples are carbon nanotubes or buckyball like that is there. Nanotechnology is not new to everyone. That is, it is older days itself nanotechnology is used, but we don't have aware about the nanotechnology technology used. That is, the examples are all Ajanta Ellora paintings. Paintings are still there because of the colors. Color is still there because of it. The particles used for the paintings is in nano range, so that only the painting remains still now also. And the liquor's cup means that is two colors emits. When the light induced inside the cup, the color is green color. When the light induced outside the cup, it emits the red color because of the absorption range. That is above that, the one gold nanoparticle can emit many kind of colors, depends upon the size. That is an example. That, and also medieval stained glass also is there. It is also nanoparticles are used. And then nanofabrication done by two methods: top-down nanofabrication, bottom-up nanofabrications. Nanomaterials have a large surface area when compared to the same material mass of the material produced in large form, and also it is many more chemically reactive, and after their strength or electrical properties. Quantum effects will dominate the behavior of the matter at the nanoscale. And nanomaterials can be divided into three types. That is a 0 dimension, 1 dimension, and 2 dimensions categories. And the optical properties are directly dependent on the size. That is an example for nanoparticles, how they are be. That is an gold nanoparticles, silver nanoparticles. It depends on the size. The absorption range will be different. And then one material we can emit more kind of colors. That is, you can see in the figures that they have blue color to red. One material, that is an AG materials. That is silver nanomaterials, silver nanoprisms, 100 nanometers, and gold nanospheres 100 nanometers, gold nanospheres 50 nanometers, spheres at 120 nanometer, 80 nanometer, 40 nanometer. There is different colors it will emit, depends upon the size. That is a peculiar property of the nanoparticles. The side also, in the size figures also, many kind of things seen that different colors, depends on size. Application nanoparticles, in all field nanoparticles are used: textile, renewable energy, environment, electronics, industrial, and food, agriculture, health, and biomedical, etc. Many kind of applications. In nanomaterials are used for supercapacitor electrodes, particularly carbon-based electrodes. That is because of high surface area, increase in the capacitance values, and high conductivity because of the graphene materials like graphene materials have high conductive materials. And then high surface area, like both things, that is EDLC, electrical double layer capacitance, and pseudo capacitance also form in like in composites. You can achieve in that, so that we can reach many higher capacitance values. Fully combine accessible high surface area and high conductivity because of unique properties. Many researchers are attracted. I can use as an allied material for energy-related applications. Graphene can easily functionalize. It is a more material, easily functionalized, and with redox materials for enhancing the energy density also. Limitations means that there is a diffusion resistance and leading to a low power density. That is the limitations, and the degrade in the cycle stability. Nanometer supercapacitors, it is a previous issue, and then in the many kind of materials are used in that ruthenium oxide, manganese oxide, and polymers, and many kind of materials are used for the supercapacitor applications. In that, ruthenium oxide shows some higher capacitance value compared to other things. Composite material, it is a composite material, ruthenium with other carbon materials. Coming to the graphene. Graphene is a peculiar material and and also a very versatile material used in many kind of applications nowadays. And for the invention of graphene, then Andrei, Jim, and then Russian scientist Kostya Novoselov, both the scientists received the Nobel Prize in 2010 for discovery of graphene. Graphene is a monolayer of one layer of graphite. That is an graphene. He invented in the both. He is an Andre is an supervisor, and then question supervisor, then student of for him. For both the student and the guide received the Gomel Prize for the invention of graphene. You look at the figure that is above the flower, the carbon material stands on that. The petals are not been affected. It shows that how much light element it is. That is a graphene material, very light material, can be used many kind of applications because of its own property, inherent property. It is graphene is a one atomic thick planar sheet of carbon atoms that are densely packed with honeycomb crystal structures. It has an interplanar spacing of 0.335 nanometer, and also the bond length is approximately 0.142 nanometer. It is an allotropes of including graphite, charcoal, CNT, or fluorines also. It is an allotropes of carbon. Graphene structures fundamentally is a starting material of variety of fluorines and buckyball carbon in tubes. It is have a, if it is tubes, it is if it is tube means carbon nanotubes. If it is a round shape, spherical shape, means it is in a fluorines, and it is in a one structure. It is a one layer means it is graphene. That is an structure of the carbon materials. Production graphene researchers relatively produce large graphene sheets, eventually up to 100 micrometers in size. Mechanically extrapolation methods like 3D graphite structures. Another method is a heat silicon carbide to high temperatures at 1100 degrees Celsius to reduce it into graphene. By oxidizing the graphene flakes, then floating them in water, and the graphene flakes are from single sheet and bond very powerfully, called as graphite paper. And common method, and all the laboratories where research laboratories are used, modified CMOS method is only method used to prepare the graphene materials. That is, properties of graphene is high electronic properties, can almost no resistance, generating little heat, and mobility of graphene is 200 times more than that silicon. It is mobility. Electrical conductivity is approximately 64 meter second per centimeter, 60 times more than that of the single wall nanocarbon nanotubes. That is an electronic properties. Thermal properties nearly graphene measured to between 4.8 to 0.4 and 10 power 3 to 5.3 plus or minus 0.48 to 10 power 3. That is thermal properties. More than carbon, copper and graphite. Thermal properties. Mechanical properties, it is also very stronger. Graphene is a thinner ever, but also stronger than diamond and steel. And graphene sheets are flexible, used to flexible electronic and storage devices as compared to the graphite, which is brittle. And surface area is approximately 2,630 meters square per gram, more than the graphite. And then single carbon nanotubes almost completely transparent, yet to dense that there is not even helium can pass through it. That is an properties of graphene, mechanical properties. Synthesis one, it can be two methods to cleave the multi-layer graphite into single layers by depositing one layer of carbon into another material. That is an extrafloration and epitaxy. Drawing method is one of the one. It is in the above that graphite material, we can stick a adhesive one and peel off the upper surface. That is a method of drawing method. Peel offing means we can sticking and peeling. That is a method. That is not an effective one. And graphite oxide reduction method is an modified method. It is used, many people are used. It is, and also purity is also very high in method. Epitaxy is only silicon carbon epitaxy, and then metal substrate epitaxy. That is growing the carbon layer on a substrate using the different versatile methods, chemical vapor deposition, like that. Modification of graphenes, can encapsulate any material for different kind of applications. Also, we can wrap on any material using the layers, and also we can anchor the nanoparticles on the graphene sheets. We can also make the novel architectures. Any kind of modification can be done using the graphene materials. Depends upon the application, so that only it is used in many kind of different applications also. Application of graphene, it is very high applications, very high variety of application, display screens, harder substrate but flexible, lightweight, very expensive and not brittle, can use either in electronic gadgets. Also, and also the trending future applications, that is an bulletproof wear and a bulletproof glass, replace expensive items, and neuroscience, DNA sequencing technology, and also eye contact. That is, you can also reduce in the lens like materials. Also, you can use a graphene material because of the transparency. composite materials are being graphene-based metal oxide composite is used for supercapacitor application because of its own property, because combining the two synergetic effects, that is an combining the metal oxide with the graphene, we can achieve EDLC and pseudo-capacitance, both the things. We can achieve the higher capacitance value. Few applications, that is, we have done the research work in the about molybdenum disulfide nanosheets and graphene material, nanocomposite. We have prepared using the hydrothermal method, and in that we studied many kind of properties. In the XRD, we formed that MOS2 and graphene, that is a molybdenum disulfide nanosheet with the graphene, with the external structure completely matching with the resistance value, and also the peaks also aligned with the resistance value, matching the resistance value. And then extra 2 peaks are formed because of the both the molybdenum disulfide nano, it is also sheet, and the graphene also nano sheet, but and stacking one by the one, and the extra 2 peaks are formed. It is shown on the side figure also. We have illustrated in there. And then same picture, we can same morphological studies. It can show the it is showed that the sheets of formation is clearly seen, and also the molybdenum disulfide nanosheets also seen upon the graphene sheets, and also in attacks also there is no impurity formed on the samples. This is beautifully the sheets formation is there. Raman's conformation of the carbon materials and the D and G bands of the graphene, it shows the formation of the carbon materials. D and G is a major peak should be present in the carbon material. If it does not present D and G bands, means there is no carbon present in the sample. It is in the range of 1350 centimeter inverse and then 158 centimeter inverse. That is the and molybdenum peaks also is there. And then XPS and bed, we have the properties of the element and the pores, the diameters of the material, composite material. It is 2 to 7 nanometer pores are present, and then exhibit the surface area 6.64 meter square per gram, whereas the surface area of composite is very high, that is 365.8 meters square per gram composite material. This coming to the electrochemical studies, if a supercapacitor application means you should study about electrochemical studies, then only you can for the supercapacitor properties. CV studies, the CV studies we have potential versus current density, that is the potential range with current density. We studied the three electrode systems for different. The figure shows that composite material, pure material, and the graphene oxides. The curves are all doesn't show that the reduction and oxidation peaks, which shows that EDLC behavior is there in the sample, and also majority of the carbon material, carbon content is present, and so certainly it does not show the pseudo-capacitance value. And charge discharge curve with time versus the potential, discharge time is calculated with the specific capacitance value for the pure and the composite samples. We have the composite sample shows a higher specific capacitance value compared to that of the pure samples. It shows a higher capacitance, that is 270 farad per gram. And also the efficiency, Coulomb efficiency depends upon the cycle number. That is 92% cycle efficiency is retained in a current rate of 0.6 ampere per gram. It is higher Coulomb efficiency is formed in the sample composite samples, and also power density is very high for the composite samples. In the impedance, electrochemical impedance, it shows then charge transfer resistance for the composite sample is 64 ohms, and the pure sample is 78 ohms. It is a higher charge transfer resistance in pure is there because of the poor connectivity of the material. And then composite shows a fast composite sample shows the faster charge transfer rates compared to the pure material. Second work is in the graphitic carbon. It is an one of the carbon materials is bismuth sulfide nanocomposites. The XRD shows that formation of the composite sample purely it is orthomic structures. It is completely matching with the JCPD's value. Morphological studies, it is the figure shows that rods like structure is formed on the graphene, I mean, the graphitic carbon surface, and also it is in the EDS pattern there is no impurities present, only present carbon and bismuth and sulfur and nitrogen is also present in the samples. It shows the purity of the sample. And the electrical studies in the CV, the like an carbon materials, the EDLC behavior is present in the sample, and also the charge discharge curve. A higher time is achieved for the composite sample than the pure samples. Coulombic efficiency also 94% is present, 98% is present for the pure sample compared to the composite sample. We are higher than that of the pure samples. We have performed before studies around with the 3 electrode systems with the standard electrode system, AGCL, and then working electrode and counter electrode. For practical applications, we only 2 electrode systems we should study. That is an positive and negative electrodes. Working electrode as an positive electrodes, and negative electrode as the activated carbon. We used as a negative electrode as activated carbon. We studied with the 2 electrode systems, and also we have also blown on LED using the prepared samples. It also retained about 6 minutes for discharging time for after charging the electrodes. And also we have used PBA, Na2SO4 as electrolyte between them and anode and cathodes. And in that we have also achieved a higher specific capacitance value, 82 farad per gram, in a potential of 2 volt potential is higher potential values. That is a 2 volt potential. We are given a 2 volt potential for studying the 2 electrode systems. Okay, like that way, the carbon materials are mostly attracted by the researchers. Many kind of application is going on. In the future, kind of applications like that only. That is sort of photo supercapacitor replacing graphene-based intermediate bifunctional electrodes. We are using both the supercapacitors and then solar cells like that, coupling together for the one applications. This kind of future technology is going on. Researchers are all researching about this kind of work. Carbon-based materials. Like a last slide, that is in future cities, energy storage cities, how look like means that is then all things will be energy storage material. Each and every person they will be like harvesting some kind of energy like that. We are first with the solar cells and windmills and hydrogen storage. And then it is used for many kind of applications like trains, buses, like that. And then it is geothermal also is there, and the solar cells with small applications in the portable applications like that, and car and bikes, everything will be coming with electric vehicles like that. Will be there. It is the future cities will be growing up. In future, we can be seen like this kind of cities in our country also. Thank you for your time and attention. If you have any queries means, small queries means, I can answer you. Thank you. Organizer. Sir.
Thank you, sir. It's a really very nice presentation and a very good informative one. And now the section is open for the audience. You can interact with the guest. If you have any queries or clarification, you can interact with the guest now.
It's time for asking question. If anyone wants to ask question, you can proceed or type your questions in chat box.
Sir, there is one question, sir. Can you please explain the working of a supercapacitor once again? This is the question from
Yes, sir.
Mahesh.
Yes, sir. 1 second, sir.
Okay, sir.
Sir, my slide is visible. Sorry. Yes, sir. This is an schematic representation of supercapacitor. That is a capacitor value. Electrodes will be there in between the insulator will be there. The electrolytes will be present in between the two electrodes. The charges between the two electrodes will be separated. The electrolyte, the charges will be attracted on the electrodes. This is during the charging. Discharging means we are losing that charges towards the electrolyte combination. Again, combining with the material, that is an electrolyte material. That is Na2SO4 means Na2 plus and SO4 minus, like that will be separated. The Na plus will be attracted to one electrode, SO4 minus will be attracted to another electrode. It will be charging. And when again the combination will have the Na2SO4 during the discharging. That's like this will be going on, sir. That is an working principle of the supercapacitor. Can you understand? Sir? Hello?
Yes, sir. Yes, sir. Thank you for your kind explanation, sir. The another question from the chat box from Pandishwari or Nano. How far carbon-based material for suitable for chemical sensing applications, sir?
Chemical sensing applications, sir.
Yes, sir.
It depends upon the one example, a common example I will tell. That is an I have an Tamil tell Tottan Senigi. That is which person is asking, sir? Even Tamil Nadu or out of Tamil Nadu, sir? Hello?
I think she is out of Tamil Nadu, sir.
Okay. It is. I will tell in English. It is
Touch me not plant,
what
sir.
plant is there that you have a sensible plant. If you touch the plant, it will have an sense. It will be closing the leaves and all. Right? Same kind of thing because of it is an touching sensing. It is a property is there in the upper surface. Like that, the materials sensing application depends upon the size of the particle. There is issues. It depends upon the material also, what kind of materials. And carbon materials is if you used the carbon material mean due to the high surface area and the high conductivity. That is a major thing. Conductivity is a major one for the sensing applications. For that only we are using the carbon materials for sensing applications. That is a major issue, reason for using the chemical sensing applications. Compared to other conductive materials, graphene is one of the highest conductive material. I already shown in the slide. Highest conductive material is it ranges from. I also showed that value also. I think so. Right? Yes.
Yes,
That
sir.
is an
Yes, sir.
it's a thermal conductivity. There are all properties there, and also high. Transparent also. This is one because of that only it is used in many applications. Mobility connectivity also. Okay.
Yes, sir. Thank you for your kind explanation, sir. That
Yes, sir. Yes, sir.
plant was regarding to that touch me not plant, sir. Yes.
Yes, sir. Yes, sir.
So next question is, how did you calculate the current density of the device? One of the scholar from PSG college, her name was Nani Mekla. How did you calculate the current density of the device?
Current density. Yes.
Yes.
In the already many researchers been applied. I will show that formula. Yes, that is energy density is 0.5 CV square by 3.6, and it is from this using this formula. We will calculate energy density. Power density is E into 3600 by D. That is a standard formula used for calculating the energy density, power density of a material. That is standard formula, and efficiency is delta T by del LTC. That is used for your formulas are used for the calculations. That is for pseudo capacitance. Differs the formulas differ from the EDLC behavior. Formula will be differing. Okay.
Sir, the next question is from the participant Sampath. What are the strategy which is used for increase the charge and discharge time and the preparation or to prepare the materials?
Sir,
Strategy.
can
Yes, sir.
Strategy
Strategy
charge and
used
discharge
for
time.
increase the charge and discharge time.
time? Okay.
Yes, sir. Charge and whether it can
Charge
be
discharge time. Yes.
Yeah,
I understand, sir. That is
Possible.
depends upon the electrode materials. The composite materials is a major one for increasing the charge discharge time. That is, I told no carbon materials because of high surface area and on the structure of the material plays a major play role for the increasing the charge discharge time, and also the electrolytes. What kind of electrolyte we are using, and for that reason also it is the time discharge time depends upon that. And these are all the common factors which influence the charge discharge application, charge discharge times and all. Metal oxide compared to metal oxide to sulfides, different kind of charge discharge can be there because of the conductivity. The sulfides are all small conductivity, have a lower conductiveness compared to metal oxides. Like that, the different kind of parameters there to that is optimize the charge discharge times and all.
Thank you,
These are all
sir.
the
Sir, then,
yes, sir.
yes, sir. Thank you for your explanation, sir. One more question, sir, from
Yes, sir.
Mahadevan Muthukrishnan. What is the method or the simple chemical method to prepare graphene? I think, from my point of view, there is one method called modified Hammers method to prepare graphene.
Yes, sir. Yes, sir. Yes, sir. I
Whether
already told it in
any
the
other,
talk.
yes, sir. Whether any other simple chemical method has been used to prepare the graphene, sir?
Simple method is drawing method, that is peeling of the upper surface using the adhesive material and a graphite material. That is a few simple method which is adopted by the many labs. But the purity and the single layer will not be, we cannot achieve in this and that method. But common method in the lab is used modified method. It is very simple method. You can prepare in any lab. That is an purity also will come high purity also. The purity of sample can be achieved from that method. These are commonly used.
Sir, once again, thank you for your kind information and thank you for your patient for giving the wonderful explanation for the questions that they were asked in the chat box, sir. Thank you for your nice presentation, sir. It is a common thing that if you have any doubts or further doubts or clarification, you may ask through the Gmail, and he was already always available in the website, that is Periyar University website.
Thank you, sir. Thank you for your giving me an opportunity to some ideas have been shown in this lecture forum. Thank you, sir. Thank you for your kind attention.
Yes, sir. Over to Anita.
Thank you very much, sir, for your presentation. Really, it will be a good inspiration in our research field. We will send the feedback link in the chat box. Kindly, I request all the participants to fill the feedback form and submit it. Only participants who have submitted the feedback form can eligible to receive the e-certificate. I may request Dr. S. Segar, Assistant Professor, Department of Chemistry, to give the valedictory address. Welcome you, sir.
Yes, hello. Can you able to hear me?
Yes,
Sir,
sir.
yes, sir, we can hear you.
Sir.
So, good evening. Good evening, respected Reverend Mother C. Noel Ronnie, FSAG Secretary, Reverend Dr. E. Glita Sumangali, FSAG Principal, Reverend Sister A. John Diana, FSAG Vice Principal, Dr. R. Dinesh Kumar, Convener of this IWAFM 2022, Mrs. Devi, Head of the Department, Physics, resource person and participants, organizing secretary, committee members, teaching and non-teaching staffs. I am honored to address this gathering for today's international webinar on advanced functional materials. And because of Gonzaga family, I would like to express my sincere gratitude to our delegates and participants for their presence with their busy schedule. I consider it a privilege to deliver the valedictory address at this international webinar on advanced functional materials. Today we have 3 sessions. In the morning we have 2 sessions. In session 1, preceded by the eminent speaker Dr. S. Tamilarasan, research scientist from Arizona State University, United States of America, has shared about the surface energy, particularly for nanomaterials, which is one of the most important quantity to understand the fundamental aspects of thermodynamics. We also feel proud that we had Dr. S. Tamilarasan as an eminent speaker who had completed his doctorate from Premium Institute of Indian Institute of Science, Bangalore, and also working in a world-leading thermodynamic labs from US. In session 2, eminent speaker Dr. M. Arivanandan, Professor, Center for Nanoscience and Technology from Anna University, has shared about the nanostructured materials for energy harvesting application. And then in session 3, eminent speaker Dr. R. Thangappan, Assistant Professor of Energy Science and Technology, Periyar University, has shared about the research and development of carbon-based material for advanced storage devices, especially lithium-ion batteries and supercapacitors, which is emerging in automobile and electronic devices. I can confidently say that the aim of this international webinar on advanced functional material to motivate and to enrich the participant in the field of material science for energy has been achieved. I am sure that the webinar has made major contribution to enhance the understanding related to the materials for energy application among the participants. I am also glad to be acquainted with the participation of delegates from India as well as from US. I do hope that they have enjoyed this international webinar. And finally, on behalf of Gonzaga College of Arts and Science, we also request our delegates to give continuous support to conduct more scientific programs in near future. I once again thank each and everyone who made this webinar successful and for giving me the opportunity to share my views on this international webinar IWAFM 2022. Thank you all.
Thank you, sir. We wanted to say thanks and share our gratitude for everything we have been blessed with. Now it's time to give thanks. I request Mrs. K. Devi, Head and Assistant Professor, Department of Physics, to deliver the vote of thanks. Welcome you, ma'am.
Good afternoon to everybody present here. Gratitude is most powerful emotion that can be expressed in many ways. I feel honored and privileged to get the opportunity to propose a vote of thanks on this special occasion. I extend my most sincere thanks to the Almighty God for making today's event success. My sincere thanks to Reverend Mother C. Noel Rani, FSAG Secretary, Gonzaga College of Arts and Science for Women, for her help and support at various stages. Thank you, Mother. Today, my words are not enough to express the gratitude to Reverend Dr. E. Glitas Mangali, FSAG, the Principal, Gonzaga College of Arts and Science for Women, for being constant source of motivation and guiding us. Thank you, Sister. My sincere thanks to Reverend Sister A. John Diana, FSAG, Vice Principal, Gonzaga College of Arts and Science for Women, for her kind words and motivation. Thank you, Sister. I extend my gratitude to our Honorable Chief Guest, Dr. M. Arivanandan, Professor, Center for Nanoscience and Technology, Anna University, Chennai, Dr. R. Tangappan, Assistant Professor, Department of Energy, Science and Technology, Priya University, Salem, and Dr. S. Thamilarasan, Assistant and Research Scientist, Center for Materials of the Universe and School of Molecular Science, Arizona State University, for accepting invitation with a busy schedule. Really, sirs, your presentations are excellent and making this webinar interesting and meaningful. Thank you, sirs. My sincere thanks to Dr. S. Shekhar, Assistant Professor, Department of Chemistry, Gonzaga College of Arts and Science for Women, for guiding us. Thank you, sir. A special thanks to the organizing committee, teaching, non-teaching staff, and students for their support and coordination. Thank you, sirs and ma'ams. Once again, thank you, one and all. Thank you. Thank you so much.
Thank you, ma'am. Now we conclude this webinar. We appreciate all the participants. Thank you all for your participation and kind cooperation. Thank you.
Thank you,
We
dear
will send
participants. Now the feedback link has been sent in chat box. Kindly fill it for your certification. And on behalf of the management and the organizing committee, we appreciate your participation and we thank for your patience. Thank you so much for your contributions. Thank you.